In the first part of this lesson on factoring, we talked about taking out the greatest common factor and then determining what step you would take next based on the number of terms you had. We started with, if you have two terms, how to distinguish a difference of squares, a difference of cubes, or a sum of cubes. And so now we want to pick up with four terms, factoring by grouping, and then all the different ways that you would have remaining with three terms. All right, so let's start with four terms with factoring by grouping. So what you want to do is you want to group your first two terms together and group your last two terms together. Be sure that you include this sign of the third term when you're doing your grouping. Put it inside your parentheses. So now I'm going to take out the greatest common factor for these first two terms. So if I look at 2x squared and 2x, what is the largest thing they have in common? Well, that would be 2x. So if I take out 2x, to see what I have left, remember you're going to divide. So 2x squared divided by 2x would be x, and 2x divided by 2x would be 1. All right, then we're going to do the same thing with this second set. So for the second pair, what do they have in common? Well, they have a 3. So if we take out that 3, we'd be left with x plus 1. Now, in order to factor by grouping, what you have left in these parentheses must be identical. You cannot factor by grouping if these are not the same. All right. So now I have two terms. So here's one term right here. Here's my second term right here. And they each have an x minus 1 in common. To help us kind of envision that a little bit, let's replace the x minus 1 with y. All right, so that would be the same thing as 2xy plus 3y. You have two terms. Here's one right here and one right here, and they each have a y in common. So if you took out your greatest common factor of y, you would have left 2x plus 3. We're going to do the exact same thing over here, where we're going to take out our greatest common factor of x plus 1, and when we do, what we're left with is 2x plus 3. Now, one of the common mistakes that I see in my students is that when they take out this x plus 1, they want to make this x plus 1 squared. It's like they feel like they took out two of them. But if you come over here and look at this parallel problem that we did, when you take out y, you don't put y squared here. You took one y out of each term. If you distribute it back through, you can see you'll go right back to what you started with. And the same thing here. I had one term right here and one term right here. I took an x plus 1 out of each term, and that left me with a 2x plus 3. And again, if you foiled that back together again, you would see that you would go right back to what you had. All right, look at another one of those. So again, remember our first step is to group the first two terms and group the last two terms, being sure to include that sign on that third term inside the parentheses. So for this first pair, if we take out what they have in common, we could take out an x squared as their greatest common factor, and that leaves x plus 3. All right, for this next pair, if when you first looked at this you took out a positive 2, that would leave you with a negative x minus 3. Remember that what we have left over has to match. Here I have x plus 3, so negative x minus 3 is not going to match that. If you don't get a perfect match, something that you might want to try first is taking out your greatest common factor with the opposite sign. Instead of taking out a positive 2, let's take out a negative 2. And sure enough, when we take out that greatest common factor of a negative 2, now these are a perfect match. And again, you cannot do grouping. You can't factor by grouping if those are not a perfect match. All right, so let's take out that perfect match, that common factor of x plus 3. And literally, it's like you can put your finger over those two x plus 3s, and what you can see, the x squared minus 2, that will be your other factor. So if you have four terms, that's how you factor by grouping. All right, so we have talked about if you have two terms, if you have four terms. Now we want to focus on if you have three terms. And if you have three terms, typically we are writing this in standard form or general form of ax squared plus bx plus c. And so you'll notice that the first case we want to look at is when that constant term, that C value, is positive. Then we want to look at when that constant term or that C value is negative. And then we want to look at what if your A value, what if the number out in front of x squared is not 1? What if you have a different number there? Now, there's one little shortcut that you might want to use before you even start looking at, is my constant positive, is it negative, is my A value 1 or not? And that is something called a perfect square trinomial. If you happen to notice that your first term is a perfect square and your last term is a perfect square, then you might want to check your middle term to see if it is double the product of the first and the last. Let me show you what I mean. All right, so x squared is a perfect square and 9 is a perfect square. So x squared, of course, is x raised to the second, and 9 is 3 raised to the second. So if I take the product of the first and the last, so I take the product of x and 3, and I get 3x, and then I double that product of the first and the last, that gives me 6x, like you see right here, then that means that this is a perfect square trinomial. That means the two factors that I get are going to be identical. So if I factored this, I would have x plus 3 times x plus 3, or x plus 3 squared. Now, if you're doing your problem and you miss that, or you even forget to check for that, it is no problem at all, because you'll still catch it with your normal factoring that we're about to do. So you can choose to use that or not, whatever you want to do. All right, so out of our three patterns, again, a positive constant, a negative constant, and a leading coefficient that is not 1, let's start with what if our constant is positive, all right? If our constant is positive, then we're going to think positive usually makes us think, an addition sign makes us think of finding the sum, so we're going to remember sum, same. So what I'm looking for when I'm factoring here, remember I'm trying to factor this down to two binomials. I'm trying to, of course, x squared is going to be x times x, but for these last two numbers, I'm trying to find something that multiplies to be a positive 24 and adds to be a positive 10, thinking about that FOIL process. So it multiplies to be 24 and it adds to be positive 10. So the first thing that I want to do is I want to find all of the factors of 24. So I'm going to start with 1 and say 1 times what is 24? 24. 2 times what is 24? 12. 3 times what is 24? 8. 4 times what is 24? 6. 5 times what is 24? Well, nothing. 6 times what is 24? Well, 4. So as soon as it starts repeating, I can quit, because there's no need to write it both ways. That lets me know I've found all the factors. Now remember, we said when our constant term was positive, we were going to think positive, we were going to think sum. So I'm going to go through and I'm going to find the sum of my factors. 1 and 24 is 25, 2 and 12 is 14, 3 and 8 is 11, and 4 and 6 is 10. And so you can see right there, I'm trying to find that sum of positive 10. There it is right there with my 4 and my 6. Now I need to figure out what my signs are. And so here's where the same comes into play. Your signs are going to be the same. They're either both positive or they're both negative. And they're going to be the same as the sign of this middle term right here. So since my middle term was positive, then I'm going to use a positive 4 and a positive 6. And so again, if you'll notice, I was trying to find something that multiplies to be 24. So positive 4 times positive 6 is positive 24. And I'm trying to find something that adds to be a positive 10. So positive 4x and positive 6x does give me a positive 10x. So if you FOILed that thing back out, you would have x times x is x squared. X times 6 is 6x. 4 times x is 4x, so 6x and 4x is 10x, and then 4 times 6 is 24. So we can check it and see that it does work. All right, let's try another one of those. This is exactly the same. The only difference is this time our middle term is negative. All right, so again, I would start the same way. I'd find all the factors and I'd find all their sums, and I would be looking for the sum that would give me 10. And so the sum that would give me 10, again, is going to be that 4 and 6. This time, however, again, the signs are going to be the same. They're either both positive or they're both negative, and they're going to be the same as the sign of the middle term. Well, the middle term is negative, so that means that both of my signs this time are going to be negative. All right, so if our constant is positive, we're going to think sum, same. If our constant is negative, we're going to think difference, different, because when we think of subtraction or a negative sign, we usually think of finding the difference between two things. So we're going to start the same way. You'll notice that this looks very similar to the problem we were just doing. It's just that we have a negative sign here instead of a positive sign here with our constant. So we would start the same way. We would find all the factors of 24. So here are those same factors that we had just a second ago. Only this time we're going to find the difference of those factors. So the difference between 1 and 24 is 23. The difference between 2 and 12 is 10. The difference between 3 and 8 is 5. And the difference between 4 and 6 is 2. So I'm trying to find, remember, this middle term to be 10. So here's my 10 right here. That comes from my 2 and 12. So you can see I'm getting a totally different pair this time when that constant sign is negative. All right, so I'm going to have 2 and 10 this time. And remember we said difference, different. My signs are going to be different. One is going to be positive and one is going to be negative. The larger number has the same sign as the middle term. So my two numbers were 2 and 12. 12 is my larger number, and so 12 is going to have the same sign as my middle term. My middle term was positive. So 12 is going to be positive and 2 is going to be negative. So again, my signs are going to be different, one positive, one negative, and the larger number, 12, is going to have the same sign as the middle term. So again, if you look at this, our goal was to find something that would multiply to be negative 24. So negative 2 and 12 is negative 24, and would add to be positive 10. So negative 2x and positive 12x does give us a positive 10. All right, what if we change that middle sign to a negative? I would still start with the same factors, and I would still end up with the same pair of 2 and 12. But this time, remember that one sign's going to be positive, one sign's going to be negative. And remember that the larger number has the same sign as the middle term. So the middle term is negative. That means that my 12 is going to be negative and my 2 is going to be positive. All right, look at one more of those. All right, so for this one, our constant is a negative 15. So we're going to find all the factors of 15. So we're going to say 1 times 15. 2 times nothing, 3 times 5, 4 times nothing, 5 times 3, but we're starting to repeat, so we can stop there and feel comfortable that we've got all the factors. Because this was a subtraction sign, we're going to remember that we're going to find the difference in our terms. So the difference between 1 and 15 is 14, and the difference between 3 and 5 is 2. So I was looking for the 2, so that means that I want the 3 and the 5. Then different, my signs are going to be different, one positive, one negative, and the sign of the larger number is going to be the same as the sign of the middle term. So my middle term was negative, and my larger number is 5, so that means my 5 is going to be negative, and my 3 is going to be positive. Now, once you've worked with factoring for a while, you literally will be able to look at those problems and know what your answer is going to be. You won't need to do all of those steps. But the one thing that you may still struggle with is when you have a leading coefficient that is a number other than 1. And what most textbooks are going to tell you to do is trial and error. They're going to tell you to, if you're trying to find, for instance, the factors of 2x squared, that could be 2x times x, or it could be x times 2x, and they're going to tell you to try it both ways. The factors of negative 12, that could be 1 and negative 12, or negative 1 and positive 12, 2 and negative 6, or negative 2 and positive 6, 3 and negative 4, and negative 3 and positive 4. And I literally just have to try them all until I find the one that multiplies to give me my 2x squared and my negative 12x, and adds to give me my negative 5x. All right, so what do they mean by trial and error? Well, every one of these, the first term, x times 2x, is going to give me 2x squared, and the last term, 1 times negative 12, is going to give me negative 12 because I have found those factors. So what I need to check are my outer and inner to see what's going to add up to be negative 5x. And so you'll notice that here, if I check the outer, x times negative 12, negative 12x, and I check my inner, 1 times 2x is positive 2x. When I put those together, I get negative 10x, and I was looking for negative 5x, so that's not what I want. All right, so then I'll just move to trying the next one. So if I try the next one, I'll be trying negative 1 and positive 12. That doesn't work. Then I try 2 and 6, 2 and negative 6, and negative 2 and positive 6. Then I try 3 and negative 4, and negative 3 and positive 4. None of those worked, and so now I need to go back and I need to switch the order of my first terms. I've tried every one of these by doing x times 2x. Now I'm going to go back and I'm going to try every one of them by doing 2x times x. So again, I'm starting over with this list up here. 1 times negative 12, negative 1 times positive 12, 2 and negative 6, negative 2 and 6, and finally, of course, it's one of the last ones that I try, right? Finally, I find the one that gives me negative 5x. Now, if I wanted to expedite that process a little bit, you might notice that in each of these pairs, like I got positive 10 and negative 10, I got positive 2 and negative 2, I got positive 2 and negative 2. So if you get the right number, like let's say when I'm checking my outer and inner terms, I get 5x, but I needed negative 5x, that just lets me know that I just need to switch my signs. So I literally could cut this trial and error in half if I remembered that. But that's still a lengthy process. And then what do you do when they give you a problem like 6x squared minus 5x minus 24? Because the factors for 6x squared, it could be 1x times 6x, or it could be 2x times 3x, or it could be 3x times 2x, or I mean, you can turn that around in a bunch of different ways. And then 24? You're talking 1 and 24, 2 and 12, 3 and 8, 4 and 6 in all orders. I mean, you're going to be here all day long. It's going to take a full sheet of notebook paper to try all of those. And you try every stinking one of those and find out the thing is prime, that none of them work. At that point, I want to just like throw my computer out the window, right? So there has got to be a better way to do that, and there is. It is called the AC method. If you use the AC method, you do not have to do trial and error, all right? So in the AC method, it gets its name because we remember that we said this was ax squared plus bx plus c. So it gets its name because we're going to take a, which was 2, and c, which was negative 12, and we're going to multiply them to get negative 24. And we're going to follow the same rules that we did earlier today, that if this is a subtraction sign on your constant, then you're going to do difference. If it's an addition sign on your constant, you're going to do same. All right, so we're going to start off by finding the factors of 24. We had already done that earlier today. And because this was subtraction, we're going to find the difference. So we went through and we found the difference of each one of these. And we're looking for the one that's going to give us this negative 5 right here. Now, remember that when this is subtraction, difference, that our signs are going to be different. One's going to be positive, one's going to be negative, and the larger number is going to be the same as the sign of the middle term. The middle term was negative, and 8 is the larger number, so that means that we're going to use negative 8 and positive 3, because that's what it would take to get a negative 5, right? So here's the one thing that we do different. Because positive 3 and negative 8 are the same thing as negative 5, I can replace negative 5x with positive 3x minus 8x. They're equal. I'm just substituting. So positive 3x and negative 8x, if you put that together, that's negative 5x. So that's a legal move to replace it. Why would I want to do that? Because now I have 4 terms. And when you have 4 terms, you can factor by grouping, and it works the first time. So I'm going to group my first two terms and my last two terms, just like we did in the first part of this lesson when we were talking about factoring by grouping with four terms. I'm going to take out the greatest common factor of this first pair, so I could take out an x, and I would be left with 2x plus 3. Then I can take out the greatest common factor of the second pair, so I'm going to take out a negative 4, and I would be left with 2x plus 3. So I have two terms, one right here and one right here. They each have a 2x plus 3 in common, so I'm going to take out that 2x plus 3. Then put your finger over each of those 2x plus 3's. They're gone. And once you cover them up, you can see what you have left. What you have left is x minus 4. And y'all, that is the exact same answer that we got down here after all of that trial and error, right? All right, let's look at one more of those AC method problems, all right? So look at this one. I'm going to start off by taking A times C. So 7 times negative 7 would be negative 49. I'm going to find all the factors of 49. And then remember, because this is a subtraction sign, I'm going to do difference. So I'm going to find the difference in each of my factors. And so there's what I'm looking for right there, that 48. Then different, one sign's going to be positive, one sign's going to be negative. And the sign of the middle term tells me the sign of the larger number. So my larger number was 49 and my middle term is positive. So we're going to use a positive 49 and a negative 1. So now I've replaced the 48x with what it's equal to, the negative x plus the 49x. Now I have four terms and I can factor by grouping. So I'll group the first two and I'll group the last two. In that first pair, I can take out what they have in common, which is a positive x. And in that second pair, I can take out what they have in common, which is a positive 7. And again, you can factor by grouping when these two terms are the same. So I'm going to take out 7x minus 1. Put your finger over the two 7x minus 1s, and what you're left with is your other factor, x plus 7. All right, so here are just a few additional problems to practice with, just some more examples from what we did today. So if you want to pause the video right here and try these and then turn it back on again, then the answers step by step will be there for you to check your work.